Hey there everyone, and welcome to our lesson today. In our lesson today, we're going to be comparing the costs of various items using unit rates. So the great news about today's lesson is this is the kind of math lesson that you will actually use in your life all the time. In fact, you may already be using this in your life. You may just not call it unit rates. So yeah, let's get started. We're going to be doing this notes page, and then we are also going to take a look at numbers. Hang on a second. At numbers 6 and number 9 on the assignment page. Okay, so we're starting with example 4A on that notes page. So let's read our instructions. It says, let's use unit rates to decide which is the best deal. Be sure to use show your work and your thinking. Okay, so here it says Hannah sells M&Ms out of her giant bag at 4 M&Ms for 5 cents. Okay. The machine at the store sells you 18 for 25 cents. So here's what we're going to do. We're going to write out this first scenario here. That's the one with Hannah and her giant bag of M&Ms. We're going to write this one out and figure out the unit rate. So how much it costs per M&M. Okay? And then next we're going to write out the scenario for the machine at the store and figure out the unit rate for that, and then we're going to compare them and see what's the best deal. So let's do that. Okay, so once again, she sells M&Ms at 4 for 5 cents. So we want to figure out the cost of one M&M. So we need to put the cents on top and the M&Ms on bottom. Now for your cents, you kind of have a choice. You can write it like 0.05, or so this would be kind of like dollars, really, right? Or you can write it like 5. Both of these are totally valid, and they will both work as long as you do it the same way for the other problem. So for example, if you choose to write it this way, make sure you take this one and write it like this. On the other hand, if you write it this way, make sure you take this one and write it, excuse me, it's not 18, it's 25. So it would have been like that. But if you write it like a 5, then you would write it like a 25. So if you use a decimal on Hannah's problem, make sure you also use a decimal on the machine's problem, just so that we're comparing apples to apples, so you say, right? Okay, so now what goes on the bottom is the number of M&Ms. I'm going to do it without the decimal. I just find it's easier and it makes sense to me that way, but if it doesn't, then definitely do it with the decimal. So you have 4 M&Ms per 5 cents. There we go. And so let's find our unit rate. So basically we need to get a 1 on the bottom, just like we've been doing the last few days. So how do you get from a 4 to a 1 using multiplication or division? You're going to divide by 4. So that's what we're going to do to the bottom, and we're going to do the same thing to the top. Now to figure out 5 divided by 4, let me grab my handy calculator right here. And we're just going to put that in there. So we're going to do 5 divided by 4. 1.25. So I'm going to write 1.25 here. Okay, so that is our unit rate. And I'm just going to write it like this also. This means that each M&M costs 1.25 cents. I'll go ahead and write cents here also. Okay, let's do the next one. So because I did the number without the decimal here, in other words, I just went with cents, not with dollars, I'm going to use the 25 without a decimal also. So how many did we get for 25 cents? We got 18. Okay, now I need to figure out how much it costs per M&M. Okay, so we need a 1 on the bottom. That means you're going to have to do 25 divided by 18. 25 divided by 18. And that's going to be 1.38, and that 8 repeats forever, so I'm just going to put a line over it. So for this one, it's going to be 1.38 repeating forever cents. Okay, which one of these is cheaper? 1.25 cents or 1.38 cents? 1.25 is cheaper, so that means Hannah has the better deal. So we'll just write her name there. Does it say we need to do anything else? It says, which is the best deal? Show your work and thinking. Okay, yeah, that's all it asks us to do. So you just write the answer of whoever has the better deal, and then you can go on to the next problem. All right, so Kyle, for the next problem. Kyle sells baseball cards at 10 for 35 cents. Okay. So 35 cents per 10 baseball cards. Now we need to figure out how much that is for one baseball card. So you probably have started seeing a pattern here about the dividing. I'm going to tell you a different way to think of this. Instead of setting up equivalent fractions, if you want to, you could just take the top number and divide it by the bottom number. So if you do it that way, you're going to get 35 divided by 10, which is just 3.5. And that's the number of cents you need. So this is the same process as finding our equivalent fraction. It's just a little bit less writing. If you want to go ahead and do the writing, if that makes you feel like you're understanding it better, then by all means, keep doing the writing. This is just a little shortcut for if you want to do it. Let's go on to the other half of this problem. Is that a better deal than 12 for 40 cents at the store? Okay, let's put our cents on top. Number of baseball cards on the bottom. So what's that going to be? Let's do our 40 divided by 12. So 40 divided by 12, 3.3 repeating forever. Okay, so which number is smaller? Because the smaller number is the better deal, right? It means less money per baseball card. So 3.5 or 3.3, this is the smaller number. So it looks like the store has a better deal. So when it says, is Kyle's deal a better deal than what they have at the store? I'm just going to say no, it's not. The store has a better deal. Okay, going on to part C. At summer camp, they have Frosted Flakes and Raisin Bran for breakfast. Frosted Flakes has 11 grams of sugar in each 8.5 ounce serving. Raisin Bran has 13 grams of sugar in each 9.2 ounce serving. You are diabetic and need as little sugar as possible. Which one should you choose? Question mark. Okay, so how about we compare the two cereals and figure out the amount of sugar per gram? I mean per ounce, just kidding. Per ounce, okay? So you have 8.5 ounces in a serving here and 9.2 ounces in a serving here. So let's get that down to 1 ounce so we have our unit rate. Starting with Frosted Flakes, I'll just say FF. 11 grams per 8.5 ounce serving. Now you could do the method where you put it over 1, which means you're going to divide this by 8.5 because you had to divide that by 8.5 to get to 1. Or you could just do 11 divided by 8.5. As you can see here, it really is the same process either way. 11 divided by 8.5 gives us 1.29. So I'll rewrite it here. So basically you have 1.29 grams of sugar per ounce for the Frosted Flakes. Frosted Flakes, 1.29 grams of sugar per ounce. Okay, what's the next one? Raisin Bran. You have 13 grams of sugar per 9.2 ounces, so we'll put 13 over 9.2. This time we're just going to divide 13 divided by 9.2. And that gives us 1.41. Okay, which one of these is lower? It looks like Frosted Flakes is lower, so it looks like you should choose Frosted Flakes. Okay, so Frosted Flakes has fewer grams of sugar per 1 ounce of cereal. Let's go on to part D. The hardware store sells sparklers for the 4th of July. They charge 19 cents a piece. What does that mean? That means 19 cents for one sparkler, right? Okay, so it looks like we don't even have to find the unit rate of that one. We already know. So for the hardware store, it's just going to be 19 cents for the unit rate. We already know that one. Now let's figure out the next one. The fireworks stand charges 89 cents for 5. Okay, so 89 cents goes on top. 5 sparklers goes on the bottom. Let's divide and figure out who has the better deal. 89 divided by 5 equals 17.8 per piece. Okay, so what's a better deal? 19 cents per sparkler or 17.8 cents per sparkler? This one. So it looks like the fireworks stand has the better deal. Okay, cool. Let's go on to part E. You get 2 offers to help neighbors clean their yards. Neighbor A will give you $50 for 6.5 hours of work. Oh, that sounds like a good deal to me. Neighbor B will give you $35 for 4.5 hours of work. Sounds pretty nice too. Which is the better deal? Let's figure this out. So neighbor A, what are we trying to figure out? Do you want to figure out probably how much money you're going to get paid per hour, right? Okay, so let's put the money on top and the hours on the bottom. It looks like $50, that's the money. We'll put that on top. And the hours is 6.5. Now I find it easiest to write 6.5. So that's how I'm going to write that 6.5 for the hours. And I'll put my dollar sign up here just to remind myself that the money's on top. Okay, now let's go ahead and divide and figure out the unit rate. So we have 50 divided by 6.5, 7.69. 7.69 per hour. All right, let's figure out for neighbor B. It looks like $35. Got that right there. $35 for how much? 4.5 hours of work. So we're going to put 4.5 on the bottom. Okay, what do you think, guys? What's the better deal? We don't really know yet. Are you making your bets? Let's see. 35 divided by 4.5 gives us 7.77. Ooh, it's very close. So would you rather earn $7.69 an hour or $7.77 an hour? Yeah. Assuming you like the neighbors equally, might as well earn a little bit more per hour, right? So neighbor B has the better deal. All right, so that is the notes page. Let's just talk about the assignment really quick. So like in number 1, you're looking at applesauce, and you're just going to set up your ratios and figure out your unit rates. So 24 ounces for $1.25. So you'd put your $1.25 on top and put your 24 on bottom. Same thing here. You're going to put your 89 cents on top and your 16 on bottom. Divide them out, figure out your unit rate, and whichever one is cheaper is the one that you want to choose. It says put a check mark by the best deal. So once you divide, whichever one's cheaper, put a check mark by it, okay? Same thing for all of these groceries. It gets just a little bit more complicated down here at the hamburger rolls. And this is how it is in real life. You know, they have these different bags with different numbers of rolls in them. I call them buns. Do you guys call them rolls? I'm just going to say buns. 3 bags of 8 buns for $2.98. Or 4 bags of 10 buns for $4.25. So we can't even really compare the bags yet because they have different numbers in them. So how do we figure out the total number of buns here when it's 3 bags of 8? Looks like we got to multiply 3 times 8. So this is going to be 24 buns for $2.98. Once you have that figured out, you can put your $2.98 on top and the 24 on bottom, and then divide and find your unit rate, okay? What about over here? How can you figure out the number of buns here? 4 bags of 10? That's going to equal 4 times 10 is 40. So you'll put your $4.25 on top, your 40 on bottom. And then from this point, you can divide and compare. It's going to be a similar process down here for the greeting cards. So just keep an eye out for that. Another kind of weird one is number 9. Let's read it real quick. An 11-ounce can of condensed soup, to which you must add 1 can of water, costs $1.45. And then the next one is pretty normal. A 20-ounce can of ready-to-serve soup costs $1.29. Which is the better buy? Okay, so like the 20-ounce can of soup, that's not too bad. We just need to figure out the cost per ounce. So we're going to put $1.29 over 20, right? But for this condensed soup, let's see, it costs $1.45, so I'll put that on top. The question is, how many ounces is it? Well, let's go with the number of ounces of soup that you're actually going to eat, not the number of ounces that are in the can. Do you guys know what condensed soup is? It's like soup that's extra thick in the can, and you have to dump it in the pot. Once it's in the pot, you have to get another can full of water and add it to that. So it actually makes twice as much soup as it looks like. So basically, in this problem, if the can is 11 ounces big, and then you have to add a can of water to it, the total number of ounces of soup that you would actually be eating is going to be 22 ounces because you have 11 of the condensed soup and then another 11 ounces of water. So make sure on the bottom here, you put your 22 because that's the total number of ounces in that soup once it's mixed up. Does that make sense? If you have any questions, let me know. Thank you so much for watching. Have a great day. Bye, guys.